Welcome back to RealHouseDIY. Back at the boiler. More specifically, going to make sure this expansion tank is working properly. We're going to check that out today. I'm troubleshooting another part of the system. As part of that, I got to make sure this expansion tank is good. For the most part, your hot water boiler is a closed system full of water. Mine is generally reading about 12 psi, maybe as high as 20 psi. So basically when the system is cool, such as during the summer, when you just have the pilot light on, it's going to be low pressure. When you're calling for heat in the winter, especially a lot of heat in all your zones, your pressure is going to be at the highest that it's going to be. With that changing pressure, you have an expansion tank. As you can see on mine, it's connected right here, right after the pressure regulating valve. Dials down the water pressure from the city water supply. Then we get the expansion tank, and it goes from there through a valve, and then we have a pump and the boiler, etc. So on the expansion tank here, right about where there's these indents, that's where the bladder is. On this side it's going to be water, this side air, compressed air. So when your system is changing back and forth, cool, hot water, depending on the heat being requested, the expansion tank is going to help keep the system stable. When there's higher pressure, it's going to push on the bladder this way, fill with more water. So otherwise, without this expansion tank, your water pressure could get too high. And without any place to go, the only place it can go is through this pressure relief valve. This one is a 30 psi pressure relief valve. So if the system pressure got above 30, then it's going to leak some water out of that valve and protect the rest of the system. Now if this expansion tank were to fail, the bladder is going to break. This is going to all fill up with water. And at least on mine, there's nothing supporting this, and I can tell just by moving a tiny bit how heavy that is. You can also tell if it's hollow versus full of water. Right about there is where the water is. You can hear that difference. You can see pre-charge on this one, 12 psi. That is what the valve here should measure. So you can unscrew this cap. Just take your typical pressure gauge from bike tires or car tires, etc. And we can see right there, it's still 12 psi. If it's full of water, because it's broken, obviously, then it's not going to be 12 psi anymore. It's going to be whatever the actual water pressure is. And you also get some water leaking when you press down on that. And you can tell I just pressed down on that, some air shot out instead of water. And this should never change, but if you're testing this, on a weekly basis for whatever reason, it will slowly lose some air from pressing on that. And you can refill this to the correct PSI with a typical bike tire pump. The manual handheld pump would work just fine. And as you can see, mine is not supported in any way other than how they attached it to the pipe over here. I don't really like it though, although it's nice. You can tell that it's nice and light, not completely full of water. And they suggest you test the pressure on this once per year to make sure it's still good. These do eventually fail. When they do fail, you'll know it because you're monitoring your pressure on a regular basis. You'll notice the water pressure going a bit higher on the gauge there. And if it does get too high, then obviously your pressure relief valve will start to drip, and you'll notice that as well, which I always suggest keep a bucket under it. Even if it's not dripping or leaking at all, always keep a bucket under, because when it does drip, it might just be a little bit at a time, and it's leaking right next to the boiler down there on the floor. It's going to dry up pretty fast. You might not even know it. Better to catch it starting to fail early with a bucket under it versus when it's going to start leaking a lot. And you can see on my system, they were nice enough to put a water shutoff valve. This is the water in from the city supply. Then you have 1, 2, 3 components, including the expansion tank, and then another shutoff valve. So this is nice if you needed to work on any of these 3 components, replace the expansion tank, you just turn off the 2 shutoff valves, and then this part of the system is isolated to work on. If and when you need to replace this, you're going to turn off the heat. So the system's no longer going to be calling for heat and heating up. Let it cool down. Should cool down to somewhere around 100, 120 degrees, just with the pilot light on, keeping it warm, and that'll be fine. So when you shut off the 2 valves here to work on replacing the expansion tank, there won't be any buildup of pressure in the rest of the system. This is just threaded on. Whoever did this last, they put a whole bunch of this this pipe putty stuff in here. I'd prefer to use a wrap of Teflon tape to seal those threads. But it's just going to unscrew, take the new one, wrap a piece of Teflon tape around a couple times, screw it back on. Then check that the pressure is correct, such as on this one, 12 psi. And then you can open up the system back up, and then if you're working, expansion tank again. Now, if this does fail and you need to replace it, and the bladder has broken, it's completely full of water, the size of this, it is going to feel like a 5-gallon jug of water. So depending on how it's mounted, this one I might prop it up with some boxes underneath to hold the weight while I'm unscrewing it. Just keep in mind it's going to be heavy when you do unscrew it, so make sure you're holding on pretty well. When I first moved into this house, they actually had the expansion tank mounted vertically with the threads on the bottom, which is exactly what you don't want to do. When that happens, you screw it on the first time, open up the system to let water in, and you have an air trap with it in that vertical position. The air can't get out by going down. So ideally, the best way that this is mounted is with the threads facing up. So then when you turn the water onto the system, all the air immediately gets right out of the expansion tank. This horizontal way to mount it is okay, but it's not ideal. The system will still work, but you have a little extra stress on the pipes, everything with this weight hanging off the side. Thanks for watching. I've got plenty more boiler related videos coming up, so don't forget to hit that subscribe button.